Hey everybody, my name is Shannon Baldioli. I'm an educator at the National Air and Space Museum, and I'm super excited to join you all today with 4 teachers that I work with as a part of the Teacher Innovator Institute. I'll tell you a little bit about TII, the Teacher Innovator Institute, in just a minute, and I will let Kim, Jessica, Trevor, and Nick introduce themselves briefly when they get started. So what we're going to talk about today, we can go on to the next slide. What we're going to talk about today is I'm just going to really briefly share some things about professional development at the National Air and Space Museum and how, after you hear how amazing these 4 folks are, how you might be able to join us for professional development opportunities like the Teacher Innovator Institute. And then each of our 4 teachers are going to talk a little bit about some of the projects that they've been implementing in their classroom since they've been a part of the Teacher Innovator Institute. These folks were all absolutely amazing before they joined TII, but once we got rolling with the program, we started thinking about authentic learning and how we can connect students to real world problems and projects. So the 4 projects that are going to be highlighted today are going to talk a little bit about how these teachers bring authentic concepts to their students every day. And then we'll have a little bit of time for Q&A at the end. I'll be moderating, so I'll watch the chat. I can be putting links in the chat. If folks have questions, you can use the Q&A section as well. And I want to remind everyone too, before the session is over, that there's a survey that you can find on the right side of your screen that you could fill out as the session is ending. We can go on to the next slide, please. So just a little bit about professional development at NASM, the National Air and Space Museum. We have a couple of different opportunities that we hope the teachers across the country would participate in. The first you're going to hear a little bit more about today is the Teacher Innovator Institute. So Teacher Innovator Institute, or TII, is an intensive PD program for middle school STEAM educators across the United States. So right now we have just north of 60 teachers that are participating. We've had up to 90 in our cohorts at any given time. And teachers spend 2 weeks at the National Air and Space Museum for 2 consecutive summers in non-COVID times. And hopefully we'll all be getting back together in 2022. And the application for teachers for our next cohort opens in November. And I will share links in the chat in just a few moments. We also have virtual workshop series, which we will be hosting in mid-November, in January, and in March. We do professional development on demand, so my team and I will come to virtually or in person, depending on where you are, can come into classrooms and talk about things like teaching with objects, having difficult conversations in STEM, or just talking about some of the student opportunities that we use. And then finally, we have a YouTube playlist of teacher-related materials. And again, I'll share all of those links in the chat in just a few moments. So I've taken up plenty of your time, and I would love to kick off our teachers. So I'm going to toss it over to Kim, and she can introduce herself and talk a little bit about how she's using objects to start the year with her students.
Thanks, Shannon. So I'm Kim Muskegon, a 6th grade middle school science teacher from San Jose, California. And I'm going to speak a little bit about those object lessons that Shannon mentioned. So an object lesson is exactly how it sounds. It's any lesson you build around an actual object, whether it's a photo of it or something that they can actually hold in their hands, and how you get the students to interact and engage with it. So I teach science, being all about the NGSS SEPs that you see on your screen. Those are the ones that I've used to teach, that I've used object lessons to address, but everyone can use object lessons in their classrooms across various subjects. We use authentic artifacts in history and social studies, of course, but you can also use them in English and math, and hopefully you'll hear some things that you can use in your classroom. Object lessons are also great for building those soft skills like collaboration and communication and problem solving. And they're also a good low floor, high ceiling task as well. Next slide, please. So just to provide a little context, I begin the year doing a project-based learning unit called You're Hired, because sixth graders, this is often their first real exposure to any kind of science, and certainly science as a standalone class. So they come in really intimidated and thinking it's hard and, oh my God, I can't do this. And with all those misconceptions that scientists are those crazy old guys mixing potions. If I hear potions one more time, I'm going to die. But we work through this unit to overcome those misconceptions and help them see that they are already using scientific thinking and doing scientific processes in much of their daily lives. And I want them to realize that, so then there's strengths that we can build on and they can feel confident in moving forward in science. And I use a bunch of object lessons to help achieve that with them. Next slide. So this series is designed to teach and practice their observation skills along with their collaboration and communication skills within their groups and within the class. And it progressively gets more rigorous as their skill develops. But you can totally use any of these ideas one-off at the start of the year when you want to get them talking in groups, learning how to work together, getting to know each other, and stuff like that. And I think I've supplied a link to a description of each of these and the resources that you'll need to do them. So just to highlight one of my faves that I use early on in class, the meaningful object share is kind of like that. If you ask them to bring in 3 things, or you send them home with a paper bag and to fill up and bring back to share. In this case, you just ask them to find a single object that can tell as many things about them as possible. So that's my object there. And I can link 7 things about me to my little string doll space shuttle. And I like this activity because it challenges kids to think more deeply about the object that they're going to choose to bring in. And I like that they only have to bring one object. The kids in class, I have them, before the story is shared, I have them observe the object and guess what inferences they can make about the student who's bringing that object in. And they love doing that before they hear the story, and then ticking off in their head how many of the things that the person shared that they guessed beforehand. You could use this in a similar way when you're introducing a novel. What item would show a lot about the main character they're going to meet in the novel, and get them engaged before the reading begins. Or you might have just bring in an interesting object that they write a story about. Where did it come from? How did it get here? Or who uses it and for what? So there's different ways we can use it outside of the realm of science. Next slide, please. The activity that I'm highlighting today is halfway through our unit, and it's where we put all the separate things that we've been practicing together. So we've been practicing how to be detailed observers and how to communicate our findings. We've tried to eliminate bias as we hypothesize and gather evidence, and we've been practicing CERs. We've talked about how we would test our ideas, but to this point, we haven't really been able to do that yet because I've just been using photographs. So go to the next slide, please. So I start the class off by showing an object they've not seen and go through the motions that we've done so far. I use this photograph from the NASM archives, but ask them to do the observe, wonder, and think about how we would test this. And the words on the label really generate bias in the things the kids share out about. Baker specifically, they all think it's a cheese grater or something like that. And then I'll ask them to focus on the word cradle, and they'll come up with different ideas that get a little closer, but it kind of really hits that idea home. But they get frustrated that they can't test any of their ideas, because I'm always asking them, well, what would you do if you needed to find out what this was and you had it in your hands? So it really sets them up for moving forward to actually giving them an object. Next slide, please. Which is what happens. They get an actual object to investigate. I pick something that I hope they've never seen before, and the objective is to answer the question, what is this? So it'll be okay if you have something a few people have seen before. I tell them they're going to get extra practice in eliminating that bias, because I still want them to go through the process. It's not about naming it correctly. It's about doing all the steps and putting it all together. So I give them a Google Doc to work through the process. And there's 4 parts. So step 1, observe, wonder, and learn. So there's the object. What do you see? What do you notice? What do you want to know about it? Which will lead them into step 2, ask. So what questions do you have other than the obvious, what is this? When they've been observing and wondering, now they are getting more focused and specific questions. What is this part for, etc. So they then can move into developing tests. Now that they have those questions, they have to figure out how are they going to answer them. So they get to do their first hands-on investigation. And so they are wildly excited. And I give them free rein to do any test they can in the classroom. Where I can limit them is by saying, well, how is this going to answer your question? So we're not going to light anything on fire and stuff that they come up with. Then I'll ask them to keep a data table of the detail of their tests and the detail of their results. And now through their observations and their testing, they have a lot of evidence and they're ready to move into step 4, which is answering the question. And I ask them to write a CER to answer the question. So we took 2 classes, 2 hours to complete this. And then as our starter, I had everybody copy and paste their CERs that they wrote into a shared slide deck and shared them out that way. So the kids could see pretty quickly, rather than everyone just standing up in front of the class, that would take a long time. They could see pretty quickly the different things that other students thought it was. And they also got to share out some of the CERs that they thought were really good. And it was great to hear them praising their peers for, oh, you had some really good reasoning for that. I didn't think the object could be this, but now you're kind of convincing me. So it was really neat to see that. And next slide. In the end, we could vote on what we thought the object was based on that most compelling investigation. So that's a picture of what I gave them. I selected it because when I was first given one, I had no idea what it was, and neither did anyone I asked. Most of the students didn't know either that it was a no-touch door opener, which is how Amazon describes it. Although it does have many other uses too. So they came up with some creative ideas about it and were able to support that with evidence, which was the whole point. They didn't have to call it exactly what it was. They just had to be convincing with their evidence through their investigation to tell us what it was. I loved using this multi-tool object as a way to roll the many things we had been practicing so far into one investigation, and the kids were highly engaged. They were collaborative, but the collaboration was off the charts in their groups. And it proved to them that each of them is a scientist and they do think scientifically, which is what authentic learning is all about. And that's all I've got.
Awesome. I'm going to go ahead and take over. My name is Jessica Sadler, and I'm a middle school science teacher and STEAM facilitator in Kansas. And I'm going to be talking a little bit about a project that I do with my students on I call it like stacking seasonal learning. So we do a lot of earth and space science. And what I was finding, and it really hit home, I was reading an NSTA article, and it was talking about the different ways that you can accidentally spoil science for your students. And one of them was, in fact, being a teacher. And it was talking about the ways that we go in and you, even just the verbiage with which you write an objective, or the things that we put up on the board, or putting up a word wall too soon, all of these little kind of nuances that when I really started thinking about it, I was like, wow, that probably really does spoil that science. So whenever we are doing our space lessons and we get into the idea of seasons and even lunar cycles, I was discovering that I was doing a little bit more kind of that like rote teaching instead of figuring out a way for them to explore and come up with those relationships and why that happens a little bit more on their own. This summer, we had an introductory to Pocket Lab, and that has changed a lot of things for me that have been hard to teach in the past because we're not in space. Well, we are, but like out there to conceptualize a lot of those different things. And so for the lesson that I have done and reframed is this idea of starting with a Pocket Lab. Can you advance the slides, please? Awesome. So Pocket Lab, the one that we're talking about is the Voyager. There are a couple other models. It's the orange square in there. It's a very petite device. It's not very large at all. The black corded item that you see there is a temperature probe. And then I have a little example of the way that we can now model this in our classroom. So Pocket Lab also has a notebook feature, and that is where that bottom image where you see the globe is coming from. So students are going in now, and I'm asking them questions about what do you know, same general, what do you know about seasons? Why do you think the weather is hot in the summer where we are and cold in other places? What causes that to happen? And doing an investigation of that. So the students then, maybe I show them an example of a revolution, maybe not. It kind of depends on how my students are stacked within that hour, but we get the globes out and they actually will tape that Pocket Lab in the Northern Hemisphere in a locale close to where we are. And then we use a heat lamp and they are actually heating it up for a allotted amount of time and seeing how that difference has changed. And then we rotate the globe and move it to where would be appropriate. And they're still heating in that same spot. And then now they're starting to discover, oh, I'm picking up different temperature results. And then we make the rotation again. And then they're still heating in the same way. And they're discovering a little bit more about like, oh, this is really why that's happening. So it's a better idea for modeling the patterns and cross-cutting concepts I am discovering. I will also not let them do it, but I will pull out a heat gun and I will run a more constant temperature. This is something that I added towards that equator line. And so if you have enough, you can run even another Pocket Lab in that space. And so they're picking up on that constant temperature in that area. So that's something that we've looked at a lot that has really helped them start to get a better conceptual understanding as we begin these units. Can you advance the slide, please? After doing that, then I give them a Sphero. We have a set of bolts. So there's a picture there, but they're very small robots. They run off a gyroscope. And then the students actually use the programming and go through. And at that time, they are now building their own revolutionary scale and model going through. With the bolts, I require them to have a color change that they feel is appropriate for the season that the Earth would be experiencing at that time. They can also record their voices, give additional information. Why is this happening? What do you remember from the previous investigations we've done? And it takes them a little bit further because now they're actually making their own models of that learning that they have a better understanding of now. For some students, just based on time or success, this is where they might be done or might pause with that good knowledge. If you'd advance the slide, please. I also have others that move on to a business proposal style project. So for these students, they are hired by a company to do some geo hacking. And we talk about, again, geo, what does that mean? At this point, we've talked about it several times in our earth science units and other areas. And so we're getting into that idea of what do we know about geo and what do we know about the word hack? And they come up with idea, oh, well, people hack people's credit cards and identities. And so it's all very technology heavy. And then we discuss the way that we are going to use a technology idea to hack our land. And so they are being hired by a company to force certain areas to be in the same season all year long. Or it could be that maybe I say, if you're in this hemisphere, you need to come up with a way that they would have 2 seasons all year long and give the other part of our planet the other 2 seasons. This in the picture is a student's business proposal example. So they went with the idea of a Dyson sphere. And this is all very much more independent. These students are cruising through the other things a little more quickly. And so he went in and created a company name for himself and whipped up his models, got them laminated on the side, and then came in and gave this whole very structured, like wore a suit business proposal for why his company needed to be hired for this particular project. I've also had students go in and as part of their business proposal, they 3D printed different models for themselves. I found these kind of impressive because they're not 3D printed with the machine. They're the little 3Doodler pins, which they have a little bit of a learning curve sometimes. So the students went in and made their own like hands-on models and used them to rotate and explain that understanding to the other students, videotaping themselves, things like that nature. This is a really cool project that forces them to kind of think outside of the box with the current knowledge that they have, and it stacks upon that. And I believe that is what I have.
Hi, my name is Trevor McDuff. I am a high school science teacher in Richland, Washington, down in the southeastern corner of the state, far, far from Seattle, which everybody knows here in Washington. I wanted to talk about a couple of different projects that I've done here, and a lot of it ties back to the experience I've had with TII as part of the NASM experience, and really trying to get my head around authentic audience, authentic purpose for authentic learning for the students. Next. So one of the things that I really love is Pitsco has these straw rockets that the launchers are really, really amazing. We all love rockets, and the Estes rockets are fun, maybe a little more expensive than the Pitsco straw rocket launchers. And when they go up, sometimes they don't always come down. And getting kids to actually repeat the experiments, it's just a different kind of learning. With the Pitsco straw rockets, once you have the launchers, go ahead and click. It's a relatively simple piston there that kind of just launches these straws off. Click. And so here you can see my students. One of the things I like to do is I put these little trinket toys, and they have a distance, and their job is to collect enough data that they can figure out how to actually reach the trinkets there. So that they collect a whole bunch of data, and they analyze their data, and they start graphing their data to the point where when we start putting the trinkets out there, those are prizes. If you can actually hit those with your rocket the first like 3 tries, you take it home. But then we pull out this giant Mars map, which I was fortunate enough to get through the Aldrin Family Foundation. And there's a little video here of a different group of kids I was working with they're launching it. So we kind of did a similar thing. This is a younger group, so analyzing the data was a little harder, but this has all of the landing sites for all of the current rovers and Vikings and such on Mars. And so I don't know if we can play that video there. So yeah, so you can kind of see how easy it is. The kids just drop that piston and the straw goes out. But then another piece that I really like is Pocket Labs. And I think Jessica did a great job of introducing how she's doing that. I don't have the temperature probe, but just using this Pocket Lab, I was able to figure out how to model exoplanet research to parallel the James Webb Space Telescope. And part of that's just with the launch coming up and kind of drum up some interest and let the kids know, because everybody's heard about Hubble. And now with Webb replacing Hubble, not replacing it, but kind of taking us to the next level. It was kind of exciting to go, okay, how in the heck are we actually getting exoplanet research out of a telescope? What is that about? So go ahead and click on that. The nice thing about the Pocket Lab Voyager here, through DonorsChoose, I was incredibly fortunate, thanks to T-Mobile as well, as a donor, they cleared my list, and I got 10 of these. And so all my students can actually use them, and it's just marvelous. But right there, so it's Bluetooth, it connects to your device. Chromebook has its own app that can work in there. There's a whole bunch of sensors and like 20 different data points that you can collect off of that. A lot of times we use them for motion. We shake them. Jessica had the thermometer so you can get temperature really precise. But what I really liked about it was realizing that there's a luminosity aspect to it as well. So go ahead and click. And this is a video here showing how I have a flashlight and then a mailing tube. And at the far end of the mailing tube, the graph has started to collect there, but that's the mailing tube right there with the Pocket Lab. You can see the square right there. And we just kind of have graph going over it because that's the live feed from the Pocket Lab. When I put this pen right through there, we go through and we're making these down spikes that it's not much of a shadow. It's just a little teeny spike there, but there's different sizes and different amounts of time it's there based on how inconsistent I am in swinging my hand. But you end up having a perfect model of how the James Webb Space Telescope is going to be looking at distant stars and deciding if there's a planet going right in front of it or if there's just some anomaly in the data. So I have this set up for my students to use a pendulum and have different sizes of pendulum bobs there. And I'm very excited because for me, Pocket Lab's just a massive game changer, especially when we start diving into authentic real world research. But my favorite, and this is kind of where I want to spend most of my time, even though I think I'm halfway through, is these mid-altitude balloons. I have launched 3 or 4 of these, and I've been part of races and teams. And so the goal here is to launch it and learn from it. But at the same time, I want to go around the world because that just sounds cool. But these mid-altitude balloons are very different than what I traditionally had heard of with ballooning, which was the high altitude balloons. So if we can click next and animate. So the high altitude balloons usually go up to about 100,000 feet. You can get a very heavy payload. It's vertical data. You get a column straight up and down. It goes up for an hour, it falls for an hour, then you get in your Jeep and drive out in the woods and find it and maybe have to climb a tree or something and get it out. And they're quite expensive. One group that I did one of these with said that it was around like $25,000 or something. I'm sure you can find cheaper if you solder things yourself. But it's a lot of helium. It's a great big balloon. You use it once and then you're just kind of done. Whereas the mid-altitude balloons, go ahead and click, they only go to about 40,000 feet. So that's halfway up. And if you know your, atmosphere layers, that's right around the jet stream. And that's kind of the goal. It's pico light. We're talking like 12 grams. That's the amount of a CD. If we erase Spotify from our minds and remember CDs, the CD is about 12, 13 grams. And so that's it. That's the max of your payload, but it's a little solar powered pico satellite. And this collects horizontal data. It goes up and it goes around. I guess it's not really horizontal because it's circular, but it goes up. It can stay up for weeks. It can stay up for months. Your max cost on that is around $500. You probably get it cheaper too. And so I want to talk a little bit about some of the things I've done with that, some of the partnerships. Yeah, go ahead and click. So one of the things we did this through NASM. I found out about this and I liked it and we started talking and we were able to coordinate through NASM an entire balloon launch with 10 other teachers. Simultaneous was a live stream, click. And so it was loads of fun. And there I am. I have a different balloon than you saw at the beginning. Most of the time you have a 3-foot Mylar balloon, but I had this 7-foot, we call it a jellyfish or a body bag because it's just ginormous. And that actually goes a little higher. It lasts a little longer, and I got all the way around. So there's my starting path over on the left of the screen in Washington State where I am, and it went around the globe, and then we kind of lost it over, the Great Lakes because there was a storm. But it is solar powered, so at nighttime you lose track of it. You don't have any data coming in. Next. And then because the partnership there was so amazing, they inspired me to reach out to a local museum called The Reach, and we did something called the Equinox launch. Click. And the goal for the Equinox launch was actually to get one balloon launch from every continent within the same period of time. You don't need to all launch at the same time because you want to make sure you're maximizing your weather conditions. But we did not get one out of Europe or Antarctica, but otherwise we've had balloons launch from everyone. And it was just amazing, a great research, a great networking and coordination, a lot of teaching going on. But how do